Good morning, everyone. I'm Shota Deolusegun. This morning, we want to look at mathematics as a language of creation. So, before we delve into these mathematical notations uh, and symbols, I want us to look at the attributes of language itself. So, we use language to communicate. We use language to interact. Then language also could be used uh, as in form of relativity. So we use language to solve problems. So a typical example of using language to solve problem, we can use language to solve an international communication barrier problem. So in a situation where you have somebody who can actually interpret your own language in other language, then you can use the language to communicate with other set of people in other parts of the world. So we can use language to solve that kind of problem. Then we can use language to solve the problem of empathy. Well, let me say empathy. What I mean by empathy is being in another person's shoe. To be in another person's shoe, you have to actually be not only to be in that person's shoe, but at the same time to be at the level the person is operating. What do I mean by that? A typical example of such problem would be, let's say a child, let's say a young kid lost his toy. Now, that child, depending on how much is connected to that toy, that will determine how much it will be so devastated by that loss. But you, being a grown-up person, you might be frustrated and be infuriated by the child's action or the kid's action, because the child might be crying in response to the loss, you understand, and to you it doesn't mean much because you see it as a mere toy that okay, you could buy another toy for the child. And so if you are in that kind of level, based on your level as a grown-up person to relate to that child, then you are not in the empathy state of that child. So for you to be in empathy or in the empathetic state of the child, you need to also operate at the level of that child. So for you to adequately solve the problem, then you need to get back to the time when you were in that shoe, like when you were a child like that you once lost your toy or whatever it is. Then you'll be able to see how much that toy, how much it meant to the kid, you understand, and with that you'll be able to actually sympathize with such a child, you understand. So you can see that we have a relativity challenge right there, because being at the level you are as a grown-up person, if you relate to that situation relatively to the uh, child's state, then you won't be able to get the real picture of the whole thing. But when you actually be in that child's state and you operate at the child's level, you'll be able to solve the problem. So when you then look at that, you know that okay, being at that level as a child, then the toy will mean so much to that child. You understand? So you yourself, being in the state you are as a grown-up person, you can zoom in into some attitude, some childish, because you were once in that state, and that state, you passed that state to be the grown-up person you are. So you still have the nature in you. So when you zoom in deep into some of your childish attitude, you'll be able to know that you'll be able to actually relate well with the child. For instance, if you look at how much or how well you are addicted to your phone, then you too can see that toy is so much valuable to the child based on how much the child is addicted to the toy. So that is how to actually look at problem and solve problem. You understand? So basically, you two may be so addicted to your phone to the extent that you may neglect or ignore some necessary obligations. For instance, you may refuse to take care of your own mother who might be staying with you based on the fact that you are so much addicted to your phone. You understand? And you know that if that phone is get lost, or if that phone is lost, then you know how much you will miss the phone. That is how to solve problem. So in your own case, you might think that that your child may that your child is supposed to, attend to more important things, probably to be looking after his sibling or something like that. But you don't think like that to solve that kind of problem as a grown-up person, because you are relating with that child based on your own grown-up state. You understand? So you need to disconnect yourself from your state to be in the state of the child to solve the problem. So that is that about language. So language, we use it to express ourselves, we use it to communicate and things like that. So mathematics can as well be used in the same context. We can use mathematics like that as well. And in fact, mathematics is being used as such. And so we have relativity also in language usage, where I have a couple of my poems where I have palindromic poems. So, when you have words going the right way and you have other set of words going opposite, if you have the picture of the two, you'll be able to understand and value the usage of words more than being ordinarily used the way we are accustomed to. So same thing we have in the usage of mathematics, and we'll see that in the operation of in the operation of the real number to generate number system here. So now let's dive into it. So here we want to start with the addition operation with numbers to see how we come up with all these numbers like 1, 2, 3, 4. So we have operation of addition where we have 1 plus 1 equal to 2. Then we have 1 plus 2, 3, 1 plus 3, 4. Then we can see the number on our x-axis as 1, 2, 3, 4. Now, what we need to know is that we have interval right in between the numbers, and we could liken that to space of time interval. So we will get more into advanced illustration by using time energy wave model, and then by applying formula of everything, and we are going to actually relate that to complex number. So that is where we're going. That is what we're going to do, and I want to try as much as possible to explain this as intuitively as possible. So now we have the number 1, 2, 3, 4, 5, 6, 7. Maybe when it gets to 9, then the inventors of this number system might get stopped because they may not see 0 as number. But when we get to the operation of minus, which is subtraction, then we discover a new number, which is 0. It took a while before people could actually embrace 0 as a number. So we have 0 right there, because you have the progression forward or clockwise. You have the progression clockwise. Let me not say clockwise. You have the progression forward the way it should be, and by intuition you might say, okay, I can even go backward as well. And so in the process of trying to go backward, they are able to discover 0 as a number, and then when we continue, we then discover something unique, something different. So we say 1 minus 2, we have minus 1. Then 1 minus 3, we have minus 2. Then we realize that the retrogression of the number operation has entered through the 0 into another side. And so we have to add another set of numbers to our number system. So we have negative integers. For the addition operations, we have positive integers, but now we have negative integers. So, and we can see the retrogression right here, where we have minus 1, minus 2, minus 3, minus 4 right there. Good. So now we then have another operation, which is a multiplication. We have 2 times 1, 2, 2 times 2, 4, 2 times 3, 6. Okay, we still have our positive integer the way it ought to be, but we discover that this particular operation is doing something different. And what that is doing that is different from the addition, we can actually call it running forward at varied speed. So if we look up here, we see that the progression of our addition could be likened to walking forward at constant strides. And then the operation of the subtraction, we can liken that to walking backward at constant stride. Okay, good. So the reason I put all these ones there is for the fact that I want us to see the reality of what is actually happening. Now, what operation of addition is doing is different from what the minus operation is doing. So we know that minus is an inverse of addition, which is subtraction is an inverse of addition. But what they are doing is quite different. It's quite different rather. So you can see that subtraction allows us to go through the 0 number and then to other side of our x-axis line right here. So we can see that, and then there is a kind of contraction in this part of our x-axis, but as we progress, we'll get to know that we have contraction we have contraction right down here, but we can see that what they are doing is quite different from each other. Then the multiplication, so we now get to the stage of running forward, and so we want to run backward as well. Then we now have 2 divided by 1, which is 2. Then 2 divided by 2 is 1. Then we have 2 divided by 3. That one is 0.6. Then we have another problem. And one thing I want you to know, that I want you to realize, is that having the operation of addition, we do not have any problem. But the moment we start with the subtraction, we see that we have problem with that, and so we have to increase the number system. And same thing happens here. For the division, there is a problem because this 0.6 is another number which is a rational number. So we have to extend the number system because of that. Now, what this division is doing is even different from what the multiplication is doing. So it's more or less like the division is zooming in onto 1 to get some numbers in between, like the numbers. So the division is telling us that we have some numbers here, right from the 0 point here to the 1 here. And so we can see that that is actually zooming in. It's getting deep into 1 towards the 0 point. And so we extend our number system to include a rational uh, number. And then we have this number 5 where we have square. We have 1 square. When we square 1, we have 1. We have 2 square to have 4. Then we have 3 square to have 9. So at this stage, we are flying. So flying forward at multiple speed. So we can see that there are differences and there are discoveries as we perform operations, like we perform addition, subtraction, multiplication, division, then powers and all that. So we usually discover new things as we apply those operations. Then inverse of this square is square root. So square root of 1 is 1. We know that. Then the square root of 2 is 1.41. Then square root of 3 is 1.73. So then that one, so are we going to say we are flying backward at multiple speed? Well, that is what we call it anyways. So those are the operations that we carry out to extend the number system. And now we need to look at advanced number system. Apart from performing operations on number, we can as well solve equations. And by solving equation 2, we then get to discover some new set of number system. But that is where it's getting complicated. We'll get there. So now let's look at this equation. X raised power 2 equal 1. This kind of equation, what can we square to give us 1? To solve that, we know that when we have 1, when 1 is squared, we have 1. So the answer for this is plus or minus 1. So when you are dealing with equation, you have two answers. So you see that we have plus 1, negative 1. So when we have negative 1 plus 1, we solve that equation. Then another equation that we have is the second one, which is s squared equal minus 1. There is where problem is now. What can we square to give us minus 1? So we realize that there is nothing we can square that will give us minus 1. And that has been a big problem for a while before we could solve this particular equation. And we then know that by having this minus 1 right here, when you square both sides, then you get rid of the square of the x. And so we have plus or minus square root minus 1. So square root minus 1 is not a number that we can actually deal with intuitively. And another thing is that when we look at it, you see that the number is not even at the final destination, but the reason we're stopped right here is that we do not have a number system that can explain this square root minus 1. So we get stuck there and we now call it I. So we call it I. So that I, we call that I imaginary number. Imaginary number. And then when you now have A plus I multiplied by B, then we have complex number. And so we have complex plane. So this complex plane is a new realm entirely. It is not on real axis. It is not on it is not within our real life environment. So it's more or less like traveling beyond or traveling to another dimension. And so we have some problems in mathematics where we have operations being moved to another realm, to another dimension, And a typical example of that is at quantum level, where we have a quantum tunneling. Quantum tunneling is a situation where you have a particle disappear and reappear. So if you have like a barrier, quantum particle can travel through the barrier and reappear at the other side. So when we have that kind of situation, we don't know how to really explain that intuitively, because there is no way we can be so ascertained that the particle that is disappeared, the particle that got disappeared, is the same that reappeared the other side. So those are the issues that we have. And for us to effectively explain that kind of phenomenon, then we need to connect from the complex plane to our real plane. And to do that, we will need to attach real number. We will need to suspend the imaginary number to real number. And by suspension, we now tend to have relativity. So the imaginary number will be connected to real number, and so we can track the movement of particles in complex plane from the real world. So once they have that kind of relativity and connection, we'll be able to do that. So we'll dive more into that. Then I will explain more better. I will explain it better when we get there. So now let's look at a typical example of function that gets divergent from real axis into complex plane, or yes, I'll call it complex plane. So a typical example of such function is function which is 1 all over 1 plus x squared. Now this function is a smooth and continuous function on real axis. So when you plot this function, you have it from singularity of the negative x-axis, then it travels, then it goes up the dotted line, down like this. It's a smooth continuous function. But the problem with this particular function is when you take this function and you extend it by geometric series, then it gets divergent when the x is 1 or x is minus 1. Why? Why must a function that in our real world that is so convergent, that is so smooth and continuous, how can it get divergent on another plane? Because on our real plane it is not divergent, but when you apply the geometric series, then it got divergent when the x is 1 or minus 1. And so we need to look at how to track that disappearance, or that singular effect of that divergence. So we need to to track that by using our complex number. So then another function, that one actually it is quite understandable to say that, okay, on our real plane or on the x-axis, that one is convergent, but when it gets to a point, then it gets divergent, which is an inverse function of this, which is 1 all over 1 minus x squared. So that function gets convergent till it gets to a point where it gets divergent. So there is no problem with that. We can understand that. But this particular function that we know as a smooth function on our own real x-axis, but on the complex axis, by this geometric series get divergent, is something that we need to deal with and to see how we can solve that. Now, to solve that, we really need to understand the time energy wave model that we have right here, and we're going to look at how we can connect this time energy wave model to this complex plane, to activities in the complex plane right here. So now, what we see here, we can see here that we have convergence of mass at quantum level. Now, this time energy wave model is a visual representation of uh, of the reality of universe itself. You understand? So we have we have relativity of quantum mass to classical mass by applying formula of everything. And so that formula deals with the problem by going forth, by extending energy beyond the threshold, beyond its limit threshold. That is how the problem is solved. So it is not done the same way it has been done using some other methods, because those other methods, they are based on symmetric nature of wave. They are based on the polarization of wave pattern. And so for us to actually see what is happening at quantum level, we need to go beyond symmetric nature of wave pattern. So we need to extend energy beyond the threshold and see what is actually happening. So that's what the formula of everything is trying to do. And so in the formula, when we supply, for instance, let's say we supply the mass worth of electron into the formula, we will get the mass worth of classical mass that is connected to this particular electron mass. And so by applying it, we have the classical mass worth to be 2,277,000,000, then 250,000 kilograms. So the mass worth of this electron mass is so big. I mean, the classical mass worth of this electron mass is very, very big. And the reason is that before we could actually get this particular value using the formula of everything, then the energy is so stretched beyond its limit threshold to go into another dimension to have this real value. Now, when you look at this time energy wave model, you see that right down here, time energy interaction is being contracted in such a way to generate radiation. So for this time energy wave expansion that we have, there are two things expanding this time energy wave model. We have convergence of mass and then the radiation. Those are the two things expanding the time energy wave model. So now, at this quantum level, what the operation of particles here is quite different from the operation of whatever it is that we have at the classical level. I don't know if it is if we also have particle or we have masses being converging and things like that. But what I'm trying to say is that the operation, what they're actually achieving, what they're doing is different from each other. So now, for instance, let's look at this. We have the amplitude of the wave at quantum level as 5.7 times 10 minus 48. So when we supply this into the formula of everything, then we get this mass worth, which is 0.0000000001423 or 1432. Okay, now this value that we have is so tiny. What that is telling us is that when electron is in motion, its mass worth is different from the real mass. So in that sense, in that case, we need to actually extend energy to the level of superconductivity, where we'll be able to have a stable state, which is the low state of electron, in order to capture the real mass worth of electron. And that is what formula of everything did for us here. And another thing I want us to really know is that we can actually supply quantum mass worth to get classical mass worth, and as well we can supply classical mass worth to get back the to confirm the quantum mass worth. So the formula of everything links quantum mechanics to classical mechanics. There is no doubt about that. So when we now look at the way the connection is, we see that there is asymmetric nature at quantum level, because the mass worth that we have here is beyond what the amplitude of the wave is supposed to contain. So then it has to be compressed in such a way to have this symmetric nature of time energy wave pattern, in order to have equilibrium point that will generate singularity. So that is that. Now, from this analysis, we could see that by applying formula of everything, we have traveled beyond the real world to get the real mass of electron. So what is that telling us? That is telling us that the whole operation has traveled beyond the real world into complex world. And for us to track, because there is this relativistic connection between quantum mass and the classical mass, so we can get the mass worth and then get back to the classical mass worth. There is connection between them. And so just the same way we have this A plus IB at complex level to track it back to the real world, same way we have formula of everything, which is this. So now we can see that the function is a linear function, and from the chart, from what we have here, we see that the tracking of the complex number is even linear. You understand? So it is this connection that has traveled beyond, and so for it to be seen in the complex plane, it has to be kind of flipped. Now, when we look at what this I imaginary number, if we look at what this imaginary number is trying to drive at, now you see that we have actually traveled beyond. It is vertical like this, so we have traveled into this negative realm, you understand, by having -1. And so we realize that there is nothing we can square to give us -1. And so when we now use square root, when we square root the both sides, then we are able to arrive at square root -1 as our high. But basically, this is supposed to give us a particular number. And the number that this can give us, if it is thoroughly dissected, the number it will give us will be going towards the 0 point, whatever number this will generate. But the problem we have with this is that we do not have a number system that we can use for this particular I, and that is why we have tagged it I. So whatever number this square root of -1 will give us will be towards the 0 point. Now we can see the effort of I in trying to get back to the real world to reappear. So for it to have traveled to this realm of negative integers, it means that it has disappeared from the real world, because what our real world is this x-axis to this y-axis, this portion, this area. And if we look at this time energy wave model, the entirety of this wave is actually on this plane. So for us to have had the expansion that extended beyond, that means it has gone into this minus region, and then being in higher dimension, we now retrieve the real mass worth of electron. So same way we'll be able to track our imaginary number on the complex plane by attaching it to real number. So by attaching it to real number, then we now have relativity effect on it. Then another thing I want us to know, to really understand here, is that relativity is very, very essential. Now, there are three major fundamental attributes of the universe. There are three fundamental attributes of the universe. We have number one, time; number two, energy; then number three, space. I know some people might want to argue that space is space fundamental or not. Now, if you look at this time energy wave model, we don't have space as we have it in the fourth dimension of Einstein. Einstein compressed the whole of 3D space on this x-axis, and then we now have a time axis as this y. So in one of my videos, I had proved the reason why that could not be used to model the reality of the universe, especially the expansion of the space itself. You understand? Because it gets disconnected. Because when you travel more in space, then you see that time will be scaling towards the central zero. And for space, time is supposed to be scaling wide, just as you are expanding in space as well. So that is the challenge we have with that. But this time energy wave model, it illustrates the expansion of space the way it ought to be. And now the space as we have it, time energy, let me quickly tell you what happens inside the singularity. What happens inside the singularity is the stacking of time and energy. At that point, there is no form of relativity, there is no form of entanglement, there is no form of whatsoever. So in that, inside the singularity, time is not scaling, time is gliding. And so we have it stacked on top of energy. And so the form, the trajectory is linear. And when it gets to a point, just as like what we have in this eye, trying to flip to go back into the real world by having this particular value, then we can later have expansion that will get projected into the real world. So before you can have what that we can actually relate with in real world, then it has to be relativistic, and then there could be a form of entanglement as we have the expansion. And when it gets to the maximum point, then it will as well contract. So relativity has feature of expansion and contraction. You understand? So we need to really understand that. So now, right from that singularity, space is being compressed, being compacted in between time and energy, and they get stuck. They get stacked on top of each other. So when it now gets to this phase where it will be expanded, then we have time traveling inversely to energy. And when that happens, then space itself will be expanding, and the operation, the movement of time inversely to energy generates a lot of things. It generates mass convergence, it generates radiation, and as well generates what we know as dimensions. So for instance, I said when one dimension is more or less like a line, which is linear as we have it. So objects in this one dimension will see whatever it is that you pass through this dimension, we see it as a point, and that is the point of singularity. So when we get to 2D, we have it to be this. So this is our 2D. Now, at this point, we already have a plane, like we have a plane, like a flat surface. So that is, we have expanded flat surface. So this 2D, we already have the expansion of time and energy at this level. And so then we have time traveling like this, and we now have energy traveling like this at 2D dimension. Then this 2D, there is something I want you to pay attention to. The line, the first 1D line, has another line that is inversely related to it to have 2D. So our 3D will be the flat surface being inversely related to another flat surface. And so we now have that as a box, which is 3D. So our 3D, so the whole essence of dimensions is not having time at fourth dimension. No. Time and energy, they start right from the singularity point. So the dimension are being formed by having a lower dimension being inversely related to the higher dimension. And so we now say we have 2D, 3D, 4D, 5D, and then it can go on and go on like that. So that is that. Then another thing that we need to look at is that we need to look at nuclear fusion. How is nuclear fusion and nuclear fission, how is it related to this scenario of time energy wave model? Now we know that when deuterium and tritium, they are isotopes of hydrogen atom. So when they merge together, they form bigger mass, and that bigger mass is called helium. And that merging process is what we call nuclear fusion. But when we have a mass decaying towards singularity, that is what we call nuclear fission. Now you can see that the expansion part could be likened to nuclear fusion. That is creation of bigger masses or bigger elements. Then the contracting part, the contracting phase of this time energy wave could be likened to nuclear fission. Then one thing I want you to know is that for every atom there is a boundary limit. Now we see that when the isotope of hydrogen is formed, which is tritium becomes unstable. That is telling us that tritium has reached the edge, the extreme edge, the limit edge of hydrogen. And so if additional neutron is attached to tritium, then tritium will decay. That's what will happen to it. But when we now have the merging, at the point of merging, the energy, the repulsive energy becomes more intense. And as a result of that, they need to get additional energy to overcome that repulsive force to get higher mass, which is helium. Good. So we need to know that there are boundaries that must be conquered. There are boundaries that must be conquered before we can get all these expansions as we have it, and it can be translated or it can be illustrated as moving from one dimension to another dimension. So that is that. Then another thing that we need to know is that okay, so with that, I want the video to be short, and so I'm going to call it a day here. So if there is a part 2, if I'm going to have a part 2 of this, then it will be released later. Make sure you like the video, share it with your friends. Then very importantly, make sure you subscribe to my channel so that you will be notified for the subsequent video. Then don't forget to comment. Let me know what your opinion is, and then don't forget that this is a novel discovery. I'm going to put the publication, my research publication, link to my research publication in the description below. You can click and then use the formula to arrive at things that we have here. Thank you. God bless you. And don't forget, mathematics is a given language just like other languages. And for me to actually expatiate on this, we could see an example of that when Almighty God, well, I'm a God-made scientist, so I believe in God. So if you are a scientist that doesn't believe in God, I will implore you to have a rethink, because all these things that I even explained now, you can see that they are what? They are beyond normal. So I'm a God-made scientist. You can even get my NFT on OpenSea. If you want to have the portrait of me as a God-made scientist, you can have it. It's going to be a lucrative asset for you. So now, what I want you to know is that God gave Moses instruction to build tabernacle, then, ark. So God gave him measurement of what to use as length, breadth, height. So mathematics is given. And when you look at it, you see that mathematics is a universal language. Unlike the languages we have that, it varies across the planet Earth. You understand? So you will need interpreter to actually get rid of the international communication barrier. But for the mathematics is actually universal. And the reason we tag mathematics as being abstract is for the fact that its discovery usually the theoretical discovery of mathematics comes before the application of it. And so people now value mathematics more because they can apply it, and they have seen how it usually illustrates reality of universe. So mathematics, though we may say abstract, based on the fact that it comes before its application, and based on the fact that when you are trying to balance equation, you just get one integer from nowhere, and you say you multiply both sides by that integer, and then to balance equation. So things like that may, let us see mathematics as being abstract. But in real sense, we know that mathematics is the language of creation. Then another thing is that in my research publication, I specifically specify that the fifth force of the universe should be time. Yes, time is the balanced motion of the universe. And apart from being the balanced motion of the universe, time regulates the intensity of energy by scaling relatively to it. So time is not as elusive as people might think of time. Time is real, you understand, and we can track the movement of time relative to movement of energy as we have it in time energy wave model. So if you want to get access to time energy wave model and the formula of everything, make sure you click on the link to my research publication. Then you will see the full article of how the formula is derived and how the model is also implemented and applied for the illustration of the reality of the universe. Thank you. God bless you. I still remain my humble self. Till we meet next time.